Hello everyone. How are you doing today? How's the volume of the music? Is it too loud, too quiet? Just right. Hopefully just right. So, for those of you who do not know what we're doing today, we are starting our game development series where we are going to first take this game, Mega Man 3. We are going to break it down into all of its components, figure everything out, and then we are going to recreate it in a game engine. And as I discussed during my debut, the reason why we aren't talking about the programming language or engine yet is because once we get everything figured out, we're going to take time to analyze it and determine which engine would be best for what we're trying to do. Alright, and with that said, let me just get this drop out of my mouth real quick. Alright, so this episode will go for somewhere between an hour and a half with no breaks. Firstly, because I don't want to overload everybody on information, and secondly, I want the VOD to be digestible and something that people can go back and watch, because there's a lot of like birthday streams and stuff today, so there's a lot of people missing. So yeah, they're going to want to go back and watch this later. So the very first thing we need to do is ask, what is Mega Man 3? A lot of people in here have probably played a Mega Man game. There might be a couple of you who have not. So first we will discuss that. Mega Man 3 is a platformer game from 1990 that was featured on the Famicom/NES, one of the very first systems. Not the first, but one of the first. And it's the third iteration of the series. I went with the third one because it's actually one of my favorite ones, but also it has a lot more polish than the first two. So with that, we will go through here and watch a small bit of playthrough, just so you can see what it looks like here. Yeah, it's good. Okay. So the game opens up to a menu where you choose which level you want to go to. Typical Mega Man fashion, there's usually 8 starting levels where you go through and fight each boss, and then later on there is a castle stage. Gives you a small preview of what you'll be fighting in the level, Magnet Bomb. And now we actually get into some of the gameplay. So this is a normally left to right platformer. There are some up and down sections. And one of the interesting things about this platformer is how it divides screens. Sometimes the screens are only a single screen wide, and sometimes they could be multiple wide or multiple tall. But each section has its own cutoff point. And one of the other interesting things about it is that because of the limitations of memory back in these days, if you go back and forth between screens, all of the enemies respawn. The power-ups do not, but the enemies do, except for special like mini-boss characters, I believe. So if you go down the ladder for here, if you went down that ladder and then back up, that enemy would spawn again. So with that said, as we go through and watch this a little bit, let's talk about some of the stuff that we see. The very first thing, obviously, is players and enemies. So we'll add that to our list, and as I'm typing this list, I'll show it later. We have player, we have enemy. The player shoots projectiles, so we have projectiles. The enemy also has projectiles. We have terrain in the background. And we're outside, we also had a parallax background, so it's multi-layered. We have stage elements like the fans and such. We have pickups or power-ups. We have things like the gates, which can be interacted with. I would not be surprised, Ariel. It is a very old game. And then the other thing that we see on the screen, of course, is the user interface. Now we'll just go ahead and watch as they finish this boss and then go through the rest of these short segments real quick. Another thing that's on the screen that you can't actually see is the camera. That's controlling what keeps the character on the screen. If it doesn't need to go anywhere, it doesn't worry about centering, but you saw when we were on the outside wider stages, it's centered on the character. And there are different ways that's done depending on the game. Okay, and then we had a little bit more of a user interface thing there. And then finally we have the end of the stage screen, which shows the ability that Mega Man just unlocked. And then they also have a password system that you can use to continue, basically, but we'll talk about that later. Alright, we'll pause that for now. And then we have a couple of other things that we can discuss that aren't on the screen. One of those things is the game state. The game state keeps track of information like how many lives you have, what power-ups you have, basically stuff that needs to be carried between levels. Because there's not normally an entity that you just have that has that information in a level. You have it either on the outside, or you have it like something that's passed between the stages. But it's not something that you see, it's something that's hidden in the background. Okay, and now I will unhide my notepad window. And we can start talking about the sub-elements of all of these. So for the game state, we know that we're keeping track of players' lives. We know that we are keeping track of what stage we're on, what unlocks we've gotten. If there's a score, probably keeping track of the score there. And then also for the unlocks, how much power remaining, because they do have limited usage in this game for most things. Alright, next we can look at the player. So the first thing we notice is the player has a combination of sprites and animations. It has a state. Is it walking, run, slide, injured? We have what's called the invuln state. So in this game, if Mega Man gets hit and then gets hit again immediately after, he can't because he's invulnerable. So we'll just call this the invuln state. And then let's see, what else do we got? We got control. So that's another thing that's invisible that we'll have to add to our list, is control system, or input system, and sound system. We have collision boxes. Okay, we'll put this up here. Anyway, same thing for the enemy. The enemies are also going to have sprites and animations. They're also going to have a state. They don't have invuln states typically, so we'll ignore that for now. They will also have collision boxes. And then they're going to have an AI of some sort. And typically something that controls what powers they have. Now, let's do projectiles. First thing we have to state about a projectile is who owns that projectile, because that's going to cause some differences. If a player owns the projectile, they're not going to get hurt by their own projectile typically. So have an owner. And then we'll also have the sprites and animations. And the collision boxes. And then web of velocity, which is also going to apply to the other ones potentially. And then we'll have like an on-hit event of some sort. So next we got the pickups and power-ups. They also have sprites and animations, collision boxes, and then on pickup, which is basically the same thing for this game as on collision. That'll be the same for up here. And then I believe in Mega Man, if you walk into an enemy, it's also counted as a hit towards you, so we'll have an on-hit event for that as well. And so like on pickup, this is going to say, okay, well, this is either going to add HP or it's going to add energy or something like that. Okay, we have terrain. Terrain is also going to have sprites and animations, typically uncontrolled ones. It's also going to have collision. And that's actually, I think, about it for right now. The terrain's going to be pretty straightforward because it's just going to be our static terrain. And then stage elements and interactables we'll just combine into one. So we'll just say stage elements. These will also have sprites, animations, potentially collision boxes. A lot of the times this will have like an on-hit event, or it could also have an on-use. And then additional behavior, so things like the fans that we saw. And backgrounds. Normal, parallax. User interface. User interface is going to display current information, so like health, lives, selected power. And if we have menus, it'll allow us to look at our menus. And a lot of the times these different items have events, so like on select. And then we'll do the camera next. So the camera has what's called a viewport, which is where it's actually looking on the stage at the moment. And then it has behavior. And it has an object that it's attached to, which is 99% of the time going to be the player, most likely. And then with that, let me double check here. And then, so for the stage elements, we'll also put the screen transitions here, because those are something that we will be using as well. Okay, so the sound system, we have sounds, so like instead of actions here, so actions are things like the powers down here, so we'll change out powers with actions. And then actions typically have sounds associated with them. Same with projectiles. And then normally power-ups don't have a velocity, but what if they're on like a track or something? So we'll go ahead and add the velocity to the power-ups. Same with the stage elements, just in case we can keep that velocity there. And then, yeah, control, okay. So put these down here separate for right now. So these are all the things that we know here at the start that we need to make for this game to work. And at least inside the levels. Health. Yeah, kind of need health. Okay. And we'll continue adding to this list as we figure out more things. But now we can go over here and put these up here at the top and decide what systems do we need. So first thing, we need an input system. We need something that can handle controls. For a game like Mega Man, which is a platformer, you want to decide if you can handle controllers or not. And you want to know, like, can I rebind everything? For the sound system, we need to know what kind of sounds, what kind of music, I mean file type, because some systems support certain file types and certain ones don't. How is it buffered? Let's see here. Okay, so we have the UI system next. And how is that handled? Is it just a texture system on top of your viewport? Or is it a separate built-in system? Some engines do it one way, some engines do it the other. And let's see here. So we're going to need an animation system of some sort. So what is an animation exactly? It's a collection of sprites on a timeline, typically. And usually it also allows you to attach events to the timeline in certain places. So like if you want to do something specifically when the animation was completed, you can attach an event to that. And then we also have something called state transition, which is how do we go between animations? Do we know how, do we have to manually code ourselves? If like we land, do we keep running, or if we go into an idle animation? And this is typically called a state machine. And this will also determine, like, if we're moving, which direction are we facing? Okay. Control collision. Alright, next let's talk about a collision system here. Do we have to code this ourselves? Or is it part of our engine? And then if it's already available in the engine, does it use layers/flags? Does it use raycasting or simple collision? Since we're making a 2D game here, we don't need necessarily need raycast collisions and all of that. We just need basic balance checking. Then let's see here. We're talk about the scene system. So what is a scene system? The scene system is basically what controls your level, like how it presents and all of that. So this is what contains your camera and the rest of your level itself. Depending on your engine, some things consider entities themselves as individual scenes, and you just make a scene tree. We'll talk about that more when we get to the engine stuff. But this contains the terrain, background, placeholders for player, enemies, interactables, etc. And since we're doing a 2D system, we need to think about what kind of scene system is it. For instance, we don't necessarily need an octree system with what we're doing, because that's more suited towards 3D development. And for those of you who don't know what an octree system is, it's basically where it divides your three-dimensional scene up into a series of 8 cubes, and then if you need further granularity, it divides each of those specific cubes into an additional 8 cubes, and so on and so forth. And that allows you to have basically what's called a log-n traversal when you're trying to do detection. Okay. And I'll talk more about programming log stuff later. But basically it's saying that despite how complicated your scene can get, we won't have to like check every single thing to see if there's a collision. Alright, let's see what else we got. Physics system, yeah. Once again, do we have to code this ourselves? Or is it already present in the engine? Does it have gravity? Does it use rigid body / kinematics? Or a combination of thereof? And can it be tied into the animation system? Let's see, what else do we have? Talked about the sound system. Talked about input. This provides animations. Boxes, AI. AI, let's talk about AI next. Another, do we have to code this ourselves from scratch? Does it use a state system? Similar to, what was it, the code again? The animations. A lot of early 3D shooters use state machines to code like the behavior of your enemies. Does it use scripting? Sometimes they'll use scripting like Lua, Python, Perl. Well, not Perl so much nowadays. Perl's pretty old, but yeah, some of those other ones. I have had to work with an engine where all of the AI was coded in Perl. That was not fun. Alright, and let's see, event system. Once again, do we have to code this ourselves? Do we have an event priority? And when does it process the events? So what I mean by this specific line here, this one's slightly more complicated to explain, but let's say you had 3 people all sitting in a circle-ish formation or a triangle with each other. And there's a thing in the code that says, if you get hit, you cannot punch somebody else. Now, let's assume all 3 people punch each other at the same time. Depending on how your engine is programmed, that could cause a problem. If you do like linear processing or something like that without an extra frame of interpretation, what would happen is the first person who punches will punch the second person, and then the second person won't be able to punch, even though you told them all to punch at the same time. So if you add an extra frame buffer there for the actual event to propagate through, then all that happens on the next frame, and all three of them are able to go through at the same time. So that's why you need to ask about how that works. Okay, Go to handles, projectiles, owner, sparks animation, collision boxes. Another thing we have to ask here is, do we define the boxes on our own? Or are they generated by the system? With our system, do we need to worry about mass? We can watch more in a little while just to make sure, but I don't believe there's too much in this game that deals with mass, so I think everything has like the same general physics. Interfaces, ground parallax, viewport, and let's see here. Camera system. Are there built-in cameras, or do we have to code these from scratch? Okay. So we have a bunch of information here that we can use, and that we'll use on another day when we're talking about our engine. But for now, we can start going through and defining these and fleshing these out a little bit more. So we can go back down here to game state. We have player lives. So we know this is a number, and that we're going to have functions that either increase or decrease. And then we have an event that'll fire off when it hits 0 after we die. So we have what stage we're on. This is just going to be probably either a string or an enumeration of some sort. This is going to be either a list or a dictionary of some sort, probably. Okay, we'll have a power there, and we'll define that as a separate class later. We'll rename this to how much energy remaining for each move. This is typically going to be a number. Score number. Health number. And we'll have an event when it hits 0. Okay, so let's think about what animations we need here. We need a walk/run animation, slide animation, injured animation, shooting animation, and if special powers use any of them, we'll have to add animations for those as well. And we need to talk about what frame rate we want all this at. This is going to be a string or enumeration. This will probably just be a boolean, which is a simple true and false. Control, this will just be this will be part of the input system, so we won't do too much with that right now. We'll have to define that a bit more when we get to it. Same with the collision boxes. We don't know yet if we'll have to make those ourselves, but if we have to make them, they'll typically be rectangles just to make things simple. And it could either be a single rectangle or it could be multiple rectangles. I don't know if you guys have ever seen breakdown of fighting games, but those games have like a ton of rectangles on each character. And the velocity, this is going to be what's called a vector, a 2D vector, which has both x and y coordinates and magnitudes. So we have actions, and this is like all of the things that we can do. So move, slide, jump, shoot, and if we figure out any other ones, we'll add those. And then for the enemies, it's just going to be a per enemy thing. We still also need to figure out the frame rate for those. Collision boxes. Velocity. Health, this will be a number. And then of course it'll have an event on 0. It'll die, of course. But we know probably have like a death animation for most of them. So owner, it's going to be an entity of some sort. And when we get to defining like our actual player and enemy and all that in code, we'll have a parent class called entity that has all of those. Hey Lapis, how's it going? Hope you're doing well. We're just breaking down Mega Man 3 over here. Sleepy, it is late for you guys, isn't it? Like 11, 12? Oh, well, thank you. I hope you're able to rest pretty well. Yes, yes it is. Well, make sure to rest well. Yes, that's why we don't do it on the corporate side. We do it for fun. The corporate side sucks. Trying to burn everybody out over there. Let's see. I should do a test real quick. I want to see what the stream delay rate is here. Hi, Malik. Anyway, where was I? So I was mentioning this earlier, Lapis, but we're actually not going to talk about the language or engine until we finish the breakdown, because one of the things that I want to do is go through and be able to show people how to objectively choose which engine and language you're going to do. Instead of just choosing one, like go through and like see what your engine features are and how they could be used for what it is you're developing, since some things might work better for 2D versus 3D, or certain engines might have certain systems built in and you might have to program other ones. So yeah, just want to be able to talk about all of that. If that makes sense. Hopefully it does. Alright, let's see. Those for now. Yeah, I agree, Lapis. I've been programming since I was like 11, and I've used so many different things. All right, have a good one. Let's see, 11 years old, 31. Means I've been programming for over 20 years. Jeez, I'm old. Way too old. Okay, anyway. And then for you guys who don't know what a parallax background is, normally you have layered backgrounds. So you have like something that might be on the background here that goes along with your character, but then you could also have a further background that moves slower. And so if it moves slower, it's basically like simulating that it's further behind. And so it wouldn't move at a 1-to-1 pace with your character. It'll be simulating depth / being further back in space. Camera. So let's watch the camera behavior a little bit here. So normally the camera stays left and right centered on the player unless we're near an edge. Oh, I should probably hide this while we're talking about it. Okay. So far we haven't seen any up and down movement. I wonder if we'll get any on this stage at all. Some of the enemies in this game are pretty cute. Alright, so we still haven't seen any vertical movement yet. Just scroll through the video real quick and see if we get a good one. Nope. Is there one here maybe? Alright, so I'm not sure if this game uses any multi-screen for verticals. So if we decide we want to do that, we'll have to come up with that behavior on our own. Okay, so with our stages, go back to our notepad here. What do you think here? Level. We'll need to define what our screen boundaries are, so that way our camera knows for this particular area, do I keep going or do I not? And then we'll need to determine for the viewport, is this resolution independent? So depending on the game, if you play at a bigger or higher or smaller resolution, you can fit more on the screen. Same if you change the field of view. Do we want the player to be able to adjust that or not? Okay. So now let's talk about the actual sprites. So how are we going to get the sprites? Well, in this case, we're probably going to rip them from the ROM or get them from a website. Since we are going to use the actual game sprites, that means we cannot actually distribute this game, even if we finish it or however far we get. We cannot give those files away. This is purely for educational purposes. However, if you decide you want to find your own sprites somewhere, or you want to make your own sprites, same with the sounds and music and all of the other stuff, if you do develop all of that yourself and you make this clone, you can theoretically sell it if you want to. Though I hope you do make it slightly different than just Mega Man 3, because that'd be kind of awkward if you just re-released Mega Man 3 with a different skin. But yeah. Let's see, what else can we talk about today? Trying to think of what else we can go into, because I think the next stream will start focusing on our engine choice. Maybe I'll make a zip file of the sprites from the game so that we can use that in between. Does anybody have any questions so far from the stream today? No questions from Ariel. No, you learn, not dumb. Learn. We will all be here learning together. I'm only able to rapid fire off all this information because I've been doing it for a while. At least we don't have to do any crazy math with a game like this. Well then, you'd probably like the more complex games, like either the puzzle games or 3D games where you have to do a lot of math with quaternions and stuff. Did you like linear algebra? Because there's a lot of linear algebra in 3D math. Aha, there's a thing that we can add to the list that we didn't have down before, lighting. Since this level uses fancy lighting techniques. Also, for our game loop, we need to know how to add a pause. Let's see, another thing you can add real quick for certain entities in general. I'll just add as a player. Is it impacted by gravity? Because we'll have certain things that are not impacted by gravity in here. And I guess technically cutscene, because it does have a cutscene for a couple of things here, where it freezes. Hello Octavius, how's it going? We're just breaking down some Mega Man 3 so that we can rebuild it from scratch. Getting a few fair notes today so far. Le oink. Oink, 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 oink. Yeah, we're gonna be finishing up today shortly with the notes that we have. And then next time we're gonna go through and start talking about what engine we want to choose. And we'll do a presentation about some of the top engines right now and look at what they have and don't have for us that we can use. Let's see. Just a note about attachments. Spring. Let's see, is there anything else important? Alright, Wily's Castle. Let's skip to... Oh no, this one had 4 extra. I forgot about those. Wily's Castle, Wily's Castle. Oh, stretch and hydrate time, thank you. That eyebrow wiggle. Alright. I think we've covered what we needed to cover for today. So I will go ahead and end this and get the VOD updated to YouTube so that people can watch it. Thank you for coming and hanging out with me today. Next week we will do a fun deep dive into the different game engines and whatnot. And have a good night, everybody.